Hey YouTube, it's the Blue Lawnmower here, and today we're back with another video of Universe Sandbox Squared. And yeah, this video was supposed to go up yesterday. Unfortunately, I didn't really have time to record another video yesterday. I wish I did, but oh well. So you can see here we have simulation Saturn with rings open, and no one commented on the last video. I still wasn't expecting them to, but yeah, if you have any ideas on something you want me to do in this game, go ahead and leave a comment. I'd really appreciate it. Anyway, so you see Saturn's mass here, 95.2 Earths. We're going to bump it up to 105 Earths and see how that affects the rings. Alright. Looks like they're going... Yeah, look at that. You can see them go outward a bit. So that's nice. Does it still look like Saturn from a distance? Hang on, let me turn off trails. Still recognizable as Saturn. But we're not wasting time. We are not wasting time. 205. Oh my! He just ate everything! Definitely doesn't look like a Saturn now. Just looks like, I mean, Saturn by itself without its rings. That's what it looks like. Alright, some moons survived. Only the ones that were like really, really far out. Well, I mean, these survived. Some of the closer ones did, like within Titan's circle. But yeah. Now let's go over here into the universe, and I want to see what happens if we were to just place Earth right in between, well, another Earth in between Earth and Venus. See if it distort the sorry about that. Distort the system at all. Sorry about that. Yeah. Alright, let's turn off trails. That's kind of annoying. I hate how it does that when you speed it up. Alright. So we see the two Earths there, and you see them there. So they're traveling along that path. They seem fine. And there's Venus there. I don't know how it's doing. But, yeah. It looks like it's about in its normal position. Let's actually, before we move on, let's take a look at, this Earth. I want to see its climate. Alright, so fairly hot. You can see some ice on Greenland and Antarctica melted. You see very, very little snow just about everywhere. So yeah. And has that, I want to see also, has that affected our normal Earth? The real Earth actually got a bit colder. That's interesting. Yeah. Alright. So now what we're going to do is go to Pluto. I'm actually going to pause time. So here's Pluto. The largest dwarf planet in the solar system, I believe. Don't quote me on that. Alright, so we're going to set this in terms of the sun. So normally, Pluto's about, let me see. Alright, so calculating that That'd be 1 sextillion 310 quintillion kilograms. That's heavy. That's heavy. You would not want to be under that. I mean, if it had any gravity to have any weight. But yeah, that science in me had to say that. But yeah, this is it in terms of the sun, which is a number I don't feel like saying, but it's a very small number. I'll tell you that much. So yeah, we're just going to set this. We're going to delete all of that. And we're going to set this. Go ahead and put this 5 suns. Oh, okay, that created a nova remnant, meaning if we were to unpause time, we'd see a supernova. But that's not what we're here for. We're here for messing up our solar system. So we're actually going to see, will this work? Alright, so you can see it got considerably larger when I increased its mass back up. And did its orbit? I think its orbit kind of got distorted. The sun probably will. Yeah, it's still gravitating towards Jupiter since time is paused. But if we unpause it even for a split second, yeah, it starts gravitating towards Pluto. Alright. So what we're going to do is, you can see a little bit of Earth right there. We're actually going to go to the climate tab. And we're just going to watch and see how this affects the climate of our planet. So yeah, you can see not much is happening. We're only going at a few days a second. So let's just speed up time. You can visibly see the sun along with the inner planets are starting to move. It looks like some of the outer planets, Saturn's going straight towards Jupiter, or not Jupiter, Pluto. It's already left. Earth is getting colder, as you can see. Not just from the snow, but you can see the surface temperature right here. Alright, so Saturn might rejoin our orbit, it looks like. Neptune's actually going over to Pluto. Uranus might get flung off into space. Okay. So, it looks like... Okay, our temperature is shot up. What's likelihood of life? Okay, it's going back up. It decreased for a second. Okay, is the oceans are evaporating. Hang on. Let's look at Earth. Yep, you can definitely see some oceans evaporating. Those, gray areas, that's actually the ocean floor. But water isn't there because, it's all evaporated into gas, water vapor in the air because of how hot it is. Because obviously, heat is required for evaporation. And, actually, something else I wanted to show you guys. So this is normal daytime. But only this quadrant. Normally, as things are now, normally this entire part would be normal daytime. But this part is actually a bit brighter because of the fact that it's actually being lit up by both the sun and Pluto. And Pluto is giving off light. And this is the part where Pluto's light is hitting. So yeah, I assume the lighting there is probably about what you'd see during maybe 6:30 in the morning. I don't know. That's just a rough estimate. I'm no genius. Alright, so it looks like most of the planets either got flung off, are now orbiting Pluto, or the really inner ones, like Mercury, Venus, and Earth, actually stayed with the sun. Alright. Let's still keep an eye on our climate. And let's keep going with this. Alright, you can see our... Okay. Oh gosh! The land went brown for a second. That means the grass is catching on fire every summer. Alright, so you can see the difference between summer and winter right here. Summer temperatures average about 101 degrees Celsius, which is very hot, above the point where water starts evaporating, and winters are about 81 degrees Celsius, which is still extremely hot. So, our likelihood of life, let's look at that. A large percentage of the population is still here. Of course, there were most likely a lot of deaths. Alright, is Saturn actually back in orbit with us? Nope. Wait, is it? Where'd it go? There it is. Okay. Kind of camouflaged for a second. Alright, as we're getting closer to Pluto. Is the sun in steady orbit? Hang on, I gotta see this. Alright, time is sped up as much as my computer can handle, which isn't very big considering how crazy everything is. Saturn seems to be orbiting Pluto. Jupiter and Mars got flung off into space. And, what else? Uranus, is it getting flung, or is it barely still in orbit with Pluto? I can't tell. Neptune actually seems to be chasing Pluto. I think the Sun and our entire solar system have been flung off into space. That's how I feel. Hang on. It seems the Earth has cooled down a bit. Let's slow down time so we can look at this. Yep, Earth has cooled down to the point where you actually see some ice again near the North and South Pole. See it on Greenland and Antarctica. So yeah. So this is what would happen if Pluto got to the mass of 5 suns. Essentially, there'd be a lot of deaths and a lot of cancer because of how close Earth was to 2 stars. The ultraviolet rays would zip through our atmosphere and cause a whole lot of cancer. So yeah, wait, is it UV rays or gamma rays? I forgot. I should study because I have a freaking exam in science soon. Alright, that's something you didn't need to know, but okay. What else did I want to do? Oh yeah, another thing I wanted to do is I wanted to test how big something would have to be to cause an apocalypse. So you see, we have our lovely Earth here, just sitting. So, yeah. We are going to add something and launch it at Earth. Smallest tier is minor, I believe, so we're going into there. Feel free to correct me in the comments if I'm not correct about the smallest tier being minor. And we're just going to throw Halley's Comet at Earth and see the... Earth literally doesn't give 2 craps about your Halley's Comet. Like, what's the likelihood of life? It barely even went down. Earth just doesn't care. Alright, well, let's undo the damage by opening a new simulation. Alright. There we go. Alright. So, take out minor. A palace. Well, alright. It has a mass of I believe that's 21 quintillion 400 quadrillion kilograms. Alright, so let's just launch it directly at the North Pole and see what happens to our planet. Likelihood of life. Okay, it went down. Okay. Alright, so our likelihood of life. Well, first off, because of this, most likely about 350 million people have died just from this impact. You can see it heated up the Earth tremendously. We're going to actually look at our likelihood of life and see if it ever hits 0. And if not, yep, it's going back up. Meaning that is not enough to cause an apocalypse. So let's look at this. Okay, slow down time a bit more so we don't have to deal with the Earth rotating. And we're going to Ceres, which is 94 quintillion 700 quadrillion. So yeah, let's launch it right at the North Pole. So this should have a lot worse effect than the last one did, considering it's about 4 times bigger. So there's our likelihood of life right now. Let's watch what happens. Okay, that's not what I meant to do. Alright, let's see this. Alright, so it goes down a lot. And those fragments are not only from Ceres, but also from the Earth's crust, because it obviously chipped off and a lot of it went into space. So yeah, we've seen what the initial impact does. Now let's look at if at any point this causes an apocalypse. Alright, life likelihood is going back up. Look at these massive craters though. Like really. Oh my gosh. Alright, so new one. That did not cause an apocalypse. Granted, that killed off over probably a little over 1 billion people. But yeah. So we're going to slow down time here. And what's up next on our list? Pluto. Pluto is massive. Pluto, I already said it's massive. There's no point in saying it again. But Pluto has a very good chance. And just because I don't want this to impact super immediately, I want to just launch it a bit far. Okay, that's coming in fast. Okay, that took our life likelihood way down. Most of our population is dead now. Let's see if at any point we're at apocalypse. Oh, it's going down fast. That's apocalypse. Alright, so to cause an apocalypse, something would have to be around 1 sextillion 310 quintillion kilograms to destroy life on Earth. So yeah. Now what we can do quickly before this episode ends, we can just explore through these Earth and sphere of moons. Oh, are they in perfect orbit? I think they are. Nope. Nope. No. Whoa! Did you see that? I mean, Earth is dead. But did you see that? They all, like, collapsed in the middle. I wonder why it does that. I gotta see that one more time before we end this off. That's so cool. I want to see if that does that after a long period of time form a ring system. I feel like it might. I feel like it has a chance. We're going to give it at least a year. Alright, slow down. Okay, we're just gonna put this out. Alright, there we go. Now we're going to slow down time even more from there. And it looks like, what the? Oh my gosh, that's such a cool orbit. It's like, normally an orbit happens along with the rotation of a planet, so it should technically be going, but instead it's going like around in some kind of weird formation. I don't know. It has a decent amount of other moons still following it. You can visibly see where everything happened at first. But yeah, I'm going to end the episode there. I hope you guys enjoyed. And yeah, I'll see you tomorrow.